kN. Azer vs Tig. Who wins? Flawless welds. Reux speed kill. Redefining welding as you know it at 18 on May 6th in Bodor laser live stream.
Bodor, dare to dream.
The tension keeps rising. Strength hits 35 kN. Azer vs Tig. Who wins? Flawless welds. Reux speed kill. Redefining welding as you know it at 18 on May 6th in Bodor laser live stream.
Bodor, dare to dream.
The tension keeps rising. Strength hits 35 kN. Azer vs Tig. Who wins? Flawless welds. Reux speed kill. Redefining welding as you know it at 18 on May 6th in Bodor laser live stream.
Bodor, dare to dream.
The tension keeps rising. Strength hits 35 kN. Azer vs Tig. Who wins? Flawless welds. Reux speed kill. Redefining welding as you know it at 18 on May 6th in Bodor laser live stream.
Bodor, dare to dream.
The tension keeps rising. Strength hits 35 kN. Azer vs Tig. Who wins? Flawless welds. Reux speed kill. Redefining welding as you know it at 18 on May 6th in Bodor laser live stream.
Bodor, dare to dream.
The tension keeps rising. Strength hits 35 kN. Azer vs Tig. Who wins? Flawless welds. Reux speed kill. Redefining welding as you know it at 18 on May 6th in Bodor laser live stream.
Bodor, dare to dream.
The tension keeps rising. Strength hits 35 kN. Azer vs Tig. Who wins? Flawless welds. Reux speed kill. Redefining welding as you know it at 18 on May 6th in Bodor laser live stream.
Bodor, dare to dream.
The tension keeps rising. Strength hits 35 kN. Azer vs Tig. Who wins? Flawless welds. Reux speed kill. Redefining welding as you know it at 18 on May 6th in Bodor laser live stream.
Bodor, dare to dream.
The tension keeps rising. Strength hits 35 kN. Azer vs Tig. Who wins? Flawless welds. Reux speed kill. Redefining welding as you know it at 18 on May 6th in Bodor laser live stream.
Bodor, dare to dream.
The tension keeps rising. Strength hits 35 kN. Azer vs Tig. Who wins? Flawless welds. Reux speed kill. Redefining welding as you know it at 18 on May 6th in Bodor laser live stream.
Bodor, dare to dream.
The tension keeps rising. Strength hits 35 kN. Azer vs Tig. Who wins? Flawless welds. Reux speed kill. Redefining welding as you know it at 18 on May 6th in Bodor laser live stream.
Bodor, dare to dream.
The tension keeps rising. Strength hits 35 kN. Azer vs Tig. Who wins? The tension keeps rising. Strength hits 35 kN. Azer vs Tig. Who wins? Flawless welds. Reux speed kill. Redefining welding as you know it at 18 on May 6th in Bodor laser live stream.
Bodor, dare to dream.
Hello everyone, and welcome to Bodor's live webinar, Master Every Weld. I'm your host, Cici. In this webinar, we are diving into a hot topic in modern metal fabrication, TIG vs laser welding. Which one is better? These are two powerful techniques, but which one really meets these demands? To help us break it down, I'm joined by Alex. Great to have you here, Alex.
Thanks, Cici. Hello, everyone. Super excited to be here today. I'll be sharing some insights and real-world takeaways we've gathered from working with manufacturers around the globe.
Alex, with your experience working closely with so many fabrication teams, what kind of welding challenge are companies facing most often?
That's a great place to start. Just last week, I spoke with a metal furniture manufacturer in Italy. They're facing the same problems we hear over and over again. High labor costs, low efficiency, and frequent rework due to inconsistent weld quality. It's become a reoccurring theme.
That's a reality for so many, isn't it? And to everyone watching, if any of that sounds familiar, you are not alone. So what's the solution? The good news is there is a kind of equipment that is simpler to operate, more efficient, and has better weld, right, Alex?
Yes, absolutely. Laser welding is quickly becoming one of the smartest choices available, and we're excited to show you why.
Today, we are not here to lecture about technical jargon. Instead, we are going to let the machines do the talking. We will compare the two techniques in speed, ease of use, and weld quality. But perform isn't the whole story. We will also reveal the core technology that delivers continuous laser output and show how Bodor cooling system ensures stability and durability. And of course, we will conclude a live Q&A session. Drop your questions in the chat anytime, and our team will be ready to answer. So let's dive in and discover what laser welding can really do. Before we jump into the test, Alex, could you give us a quick overview of the two welding methods we are comparing today?
Okay, well, let's start with TIG welding. This is a traditional process. A high frequency, high voltage is applied between the tungsten pin and the workpiece to break through the argon gas and make it electrically conductive. And then a continuous current is supplied to melt the base material. It's prized for precision and fine control, but it's slower, demands greater operator skill, and produces a wider heat-affected zone that can damage surrounding material. Now, contrast that with laser welding. A high-energy laser beam concentrates heat exactly where it needs to be, delivering faster travel speeds, deeper penetration, and minimal thermal distortion. The process is clean, efficient, and increasingly popular in modern manufacturing.
Great summary. So today isn't just an old versus new. It's about which method performs better in real-world conditions. On that note, what materials are we working with?
All right, let's take a look at what we've prepared. There's 2mm and 4mm stainless steel and carbon steel, 2mm and 3mm aluminium, which are common in signage, furniture, machinery, and electrical components.
Okay, Alex, I noticed filter wire on our slides. Can you explain this role and how the two methods differ?
Absolutely. In TIG welding, filler wire is critical. In most cases, it isn't optional. It's essential for weld quality, but feeding the wire by hand in perfect sync with torch movement is challenging and requires skills.
That manual feed must be tricky.
It is, especially for new operators. Even small inconsistencies affect weld appearance and strength. But with laser welding, you've got options. For thin to medium plates, you can usually weld without any filler wire at all. And when you do need filler, like on thicker materials, the system has an automatic wire feeder, which keeps the feed consistent and takes the pressure off the operator.
Perfect. Real materials, real data, real-world scenarios. Laser vs TIG. Who wins? Let's roll the first demo video. Alright, here we go. On the left, you will see handheld laser welding in action, and on the right, Tig welding using the same materials and same conditions. Laser speed is eye-opening, isn't it? It's clearly leading the race.
That's right. With 4mm stainless steel, laser welding moved significantly faster with smooth torch movement. Tig welding, on the other hand, needed a much slower travel speed and careful coordination to get proper fusion. In real-world production settings, we typically see laser operate at 3 times the speed of Tig across various materials, sometimes even more. The workpieces welded with Tig have a large thermal effect, slow heat dissipation, and are extremely hot to touch. We need to wait for the heat to dissipate.
It looks like here's some warping on the Tig workpiece.
That's a common issue with Tig, mainly because of its wider heat-affected zone. The surrounding metal absorbs more heat, which can cause edge lift and distortion, especially on thinner materials. And the thinner the plate, the more noticeable that warping becomes. To help you see the difference more clearly, we also ran tests on 2mm stainless steel, which really highlights the effect.
Great, let's take a look.
Now the welding begins. With thinner stainless steel, the laser welding maintained high speed and delivered a smooth, controlled seam.
The two we shall see it all side by side, and the difference is obvious. The laser ring is already started its third seam, while Tig is still midway through its first in the comparison video.
Exactly. And here's something important. When it comes to Tig welding thin sheets, there's a real risk of burning through the material if the operator isn't highly skilled. That's why Tig demands a lot of precision, training, and control. Laser welding, on the other hand, gives you stable, focused energy. So not only is it faster, it's also much gentler on the material, which makes a big difference when working with thin plates. This demo focuses on speed and handling. But don't worry, in the quality comparison part is coming up. We'll take a closer look at the deformation, especially on 2mm plates, where the differences are even more pronounced.
So, we have already seen the two techniques' performance on thin flat plates. Now I think it's time to raise the bar a little.
Absolutely. Curved or tubular parts are more demanding. We set up a side-by-side comparison on identical stainless steel pipes. Let's run the video. This is where things get really interesting. Even with curved and more challenging surfaces like round pipes, laser welding maintains a clear speed advantage. Because the laser delivers concentrated stable energy, the operator can move faster, even on complex shapes. But speed is just one part of the story. Let's talk about the ease of operation. With TIG welding, the operator must constantly manage manual wire feeding and adjust the angle and distance of the filler wire throughout the weld. That slows things down. and takes a lot of skill to get right. In contrast, Bodor's handheld laser welder offers a much smoother experience. It can be equipped with an automatic wire feeding system, which means the operator only needs to focus on torch positioning. No need to manually feed the wire. So the process is not only faster, but also far easier to learn and perform, even for newer technicians.
So it's faster, smoother, and less skill intensive. That's a big deal for workshops trying to train new staff or scale up production quickly.
Exactly. Laser welding helps you get consistent results with less effort, and that can translate into real productivity gains.
We have seen steel. Now let's tackle aluminium, which is famous Turkey. We will compare laser and TIG on 2mm and 3mm plates. Roll the video.
In this video, we're focusing mainly on
Actually go. Alex, we have got the simple pieces. Walk us through what we are looking at.
Okay, let's start with weld appearance. In the two samples here, both are 4mm stainless steel. One is welded using TIG and the other with our handheld laser welder. And honestly, the difference is obvious, even at a glance. You can see how clean and consistent the laser weld is. The seam is tight, smooth, and shows almost no spatter or discoloration. And the best part? This level of quality holds across different materials, not just stainless. Take carbon steel for example. The weld is sharp, clean, and shows minimal surface oxidation. With aluminium, which can be notoriously difficult, the laser still gives you a bright, clean seam with hardly any soot or edge burn. On the TIG welded piece, you can feel and even see some slight warping along the edges. On the laser welded side, the base material stays much more stable. There's no visible deformation and the edges remain flat, a huge plus for maintaining dimensional accuracy. In most cases, the result is so perfect, you can skip post-processing. No grinding, no sanding, just weld and move on. It's a kind of finish that not only looks professional, but also saves a ton of time and effort. And this is exactly where handheld laser welding really shows its strength, especially for industries that deal with complex or irregular welds. Because it's so easy to handle and the welds often come out perfectly formed in just one pass, it's a great fit for applications like kitchen cabinets, staircases, elevators, shelving units, and custom stainless furniture. In these types of jobs, where precision and efficiency really matter, laser welding makes the whole process simpler, cleaner, and faster.
That's really impressive, Alex. Not just in how it looks, but in how easy it fits into so many different manufacturing needs. But of course, in real-world applications, it's not just about how a welding applies. It's also about how strong and reliable it is under the surface. Can you share some more, Alex?
Absolutely. Let's start with this 4mm stainless steel sample. What you're seeing here is a full penetration in a single pass. Real output from a real weld. And to take it a step further, let's look at the tensile strength test video to see just how well this weld holds up when we put it under serious pressure. Here's what we did. We pulled the welded strip until it finally snapped. The machine recorded a peak force of 35 kilonewtons. When we convert that into stress, we get about 580 megapascals. Now, to give you some context, ordinary mild steel sheets tend to fail at around 350. So this weld is over 60% stronger than mild steel and right on par with the base stainless plate itself. And here's something really impressive. Before it broke, the welded strip stretched by 59% of its original gauge length. That level of stretch means the weld isn't just strong, it's not brittle. It can handle vibration, impact, and even forming after welding, without cracking or failing.
That's impressive. But what does that really mean in terms of practical use?
Great question. It means our handheld laser welds can actually pull harder than the base stainless. Yet, they're still flexible enough to bend nearly 60% before breaking. That's the kind of performance you want in applications like food-grade tanks, where hygiene and durability really matter. Architectural skins, where flexibility and aesthetics are key, and any thin-gauge stainless steel fabrication like elevators, kitchenware, or medical equipment. So you're getting a weld that's not only strong and durable, but also versatile and production ready.
Thanks for great insights, Alex. So let's take a moment to recap what we just saw.
Okay. Throughout today's session, we've seen how handheld laser welding consistently outperforms traditional TIG welding in real-world scenarios across flat sheets, round pipes, and a variety of materials. It's faster, often completing welds 3 times quicker. It's simpler, with one-hand operation and a minimal learning curve. It's cleaner, delivering tight, splatter-free seams that often require no post-processing. And it's more efficient, minimizing distortion, reducing rework, and significantly lowering operator fatigue. Laser welding completes the job in a single pass with minimal distortion, less surface prep, and fewer variables to manage. What does that mean for your business? Faster production cycles, fewer reworks or rejects, and much lower stress for operators, especially in high volume environments. Whether you're working with stainless steel, carbon steel, or aluminium on flat sheets or round pipes, handheld laser welding delivers cleaner, faster, and more reliable results at every step.
Alright, let's kick off this next part with a little challenge for all of you tuning in. Now you are seeing 2 welded samples, both created using the exact same laser welding machines and settings. But here is the twist. One of them was done by me, a total beginner, and the other was done by an experienced welder. Can you guess which one is from me? Sample A or sample B? Alex.
I can spot some subtle differences in the texture and the uniformity. But to be honest, for a first-timer, that's an excellent result.
Thanks, Alex. And that's exactly what we are talking about here. One of the most common concerns we hear from our customer is, can my team actually learn to use laser welding quickly? So we decided to put that question to the test. I stepped into the welding station myself, no professional background, no technical experience. Take a good look and drop your answers in the chat. We will review it just a moment. Hi everyone, I'm here at Bodor factory for a handheld welding challenge. Today, you can see our Air model and our Pro model. Our Air model has 1200 watts power and our Pro model has 1500 power, 100 watts power. And today, we will use our hand welding machine to do a test. Okay, let's start. Alright, let's reveal the answer. There it is. If you guessed symbol B, you got it right. Honestly, I was a little nervous at first, but once I got started, it was incredibly stable, and the touch was easy to control, and it was simple to stay on track. Another thing I loved, the one-cup interface. I will be honest, I'm not a fan of complicated machines, but these were totally different.
Absolutely. We just saw you using the rotary knob in the video, and now let's take a closer look at what it can actually do. And for operators, we are just getting started. We've included preset parameters for various materials and thicknesses, like stainless steel, carbon steel, aluminium, and even copper. You can change power, pulse frequency, or wire feed speed, all with a single twist. It's quick, responsive, and perfect for on-the-fly adjustments.
It's incredibly user-friendly. I was able to switch from stainless to aluminum in just a few clicks, and those built-in presets took out all the guesswork.
And that's what makes this system ideal for new operators and flexible production lines. You can train your team faster, reduce errors, and maintain consistent weld quality, no matter who's holding the torch or what shift they're on.
Alright, we have covered performance, weld quality, and ease of use. But let's talk about something every business cares about: cost. Laser welding doesn't just help your work faster, it can also seriously cut down your operating costs. Alex, walk us through where those savings really come from.
Sure, Cece. Let's start with the most obvious one: efficiency. Laser welding is fast, like really fast. So with laser, you're cutting welding time dramatically, which means more work done in less time. Compare that to the Tig welding, where the operator has to guide the electrode by hand the entire time. It takes longer to complete each weld. Next up, ease of use. Laser welders are super intuitive. You set the parameters and you're ready to go. Even someone with minimal welding experience can learn it quickly and get consistent results, which saves money on both training and labor. Tig welding, on the other hand, requires real skill. It takes time to learn and even longer to master. That means more training, higher hiring costs, and more pressure on your team. Now let's talk about maintenance. Laser systems, especially fiber laser, are designed to run long hours with very little upkeep. You're not changing electrodes all the time, you're not burning through shielding gas, and the optical fiber has a long service life. In contrast, TIG setups need frequent replacements and the costs can sneak up on you. Gas, electrodes, downtime. So if you're looking for a machine that's easier to live with long term, laser wins here too. Oh, and one more thing, automation. Laser welders can be easily integrated into automated systems, even with robotic arms. So if you're thinking about scaling up or moving towards a smart factory setup, Laser welding's already a step ahead.
Thanks for the great insight, Alex. Now we know that even though handheld laser welding can significantly cut operating costs, many of you might still be wondering about the initial investment. Well, here's some good news. We have got something special coming your way. Mark your calendars on May 13. We are hosting a special promotion live stream. Send the code number 1 to info@bodor.com to unlock exclusive webinar-only discounts. So if you have been thinking about upgrading your welding setup, this is your chance. Don't miss out. Now let's shift gears and talk about something that's becoming more and more important for manufacturers today: health, safety, and environmental impact.
Absolutely. Traditional TIG uses high-frequency ignition with a tungsten electrode, which not only generates strong ultraviolet light, but also releases high levels of ozone. Over time, this can pose significant health risks to operators, especially with prolonged exposure. Laser welding, by comparison, is a lot cleaner. It's low fume, low noise, and produces far less optical intensity.
Yeah, thank you, Alex. Up to now, we have seen how laser welding excels in speed, quality, and ease of use. Let's shift focus from performance to what keeps that performance going. Alex, here is a real question. What keeps everything stable?
The answer lies in one of Bodor's core technical strengths, our ability to deliver continuous laser output with high efficiency and reliability. Whether you're working in a temperature-controlled factory, outdoors in the heat, or in a cold, open workshop, a stable beam is critical to ensure consistent weld quality and machine longevity. That's where Bodor's cooling technologies come in. Today, I'll walk you through the innovations behind 3 of our systems: Pro, Air, and Eco, each designed to match different working environments and production demands.
That's a great point, Alex. Before we dive deeper into the technology behind our handheld laser welder, I want to take a quick moment to share something exciting with all of you watching today. For those of you in the audience who are in distribution, retail, or manufacturing support, we are also actively expanding our global distributor network. If you are looking for a trusted partner in the laser industry with leading products and global support, this is your opportunity to connect with us. Now, let's take a closer look, starting with the Pro series. Right, Alex?
Thanks, Cece. What really sets the Bodor Pro 1500 welder apart is its intelligent cooling system. Bodor developed a self-contained, closed-loop temperature control system that keeps the machine running steadily even in challenging environments. We're talking about working conditions from -20 to 60 degrees Celsius and even up to 90% humidity. The cooling system automatically adjusts to maintain optimal performance, no matter the heat, humidity, continuous 24/7 operation. You can trust Bodor Pro 1500 will stay cool, stay stable, and keep delivering results hour after hour.
That's really impressive, especially for factories running 24 hours for 7 days production lines for operating in extreme climates.
Exactly. As you can see, it's a great fit for precision-demanding industries like kitchenware, sheet metal fabrication, electrical cabinets, and custom furniture. Anywhere that seam consistency and surface finish really matter, the Pro series is the ideal choice.
Now, that's impressive. Being able to maintain stable performance even in extreme environments. But here's the thing, in real-world welding, especially out in the field, it's no longer just about how powerful your cooling system is. You need something that's compact, energy efficient, and easy to move.
Right. Now, let's talk about the Air series. This unit is all about mobility, energy efficiency, and easy operation, making it a great fit for welding on the go. Take a look at the specs on slides. It weighs just 36 kilograms. At its core, it's a phase change cooling system. It circulates distilled water through copper tubing, supported by a radiator and a temperature-activated fan. It's lightweight, power-saving, and supports a wide voltage range, ideal for outdoor jobs, mobile repairs, or remote field work, where every kilogram makes a difference.
That's a great overview of the air servos, compact, adaptive, and ready for the field. And if what you are after is advanced water cooling technology, and the Eco Servos is absolutely worth a closer look. Alex, what makes it stand out?
It features Bodor's industry leader water cooling technology, which ensures outstanding thermal control. Even during continuous operation, when welding 1mm sheet, it can reach speeds up to 190 centimeters per minute. A huge leap in efficiency compared to other 1500 watt machines in the same class. Another key advantage is the seamless coordination between Bodor's self-developed laser source and operating system. Because they're fully matched, the entire system runs smoothly and consistently with stable laser output and precise control. And for manufacturers moving towards smart production lines, the Eco Series is automation ready, equipped with an I/O port for seamless integration into robotic and automated. So whether it's the Pro, Air or Eco Series, Bodor's cooling systems are designed to keep your machines stable, no matter the environment or workload.
And that stability is key because when you are dealing with high power levels, you can't afford temperature change or power drops. Which brings us to something our users care about a lot: power.
Exactly. Let's talk about real welding strength. Because when it comes to joining materials, especially thick materials, it's not just about having a high wattage label on the machine. What really matters is whether that power translates into deep, stable, high-quality penetration. And that's a pain point we hear all the time. There are plenty of machines on the market today that don't actually deliver the full rated power they advertise.
That's where Bodor stands out.
Yes. Our handheld laser welding systems use high-quality laser sources and an optimized optical path design. What does that mean? At the same power level, Bodor machines can achieve deeper penetration than most comparable welders on the market. Let's take a look at the chart on the screen. Here you'll see a side-by-side comparison of Bodor's welders and other machines in the same class. Under full power conditions, Bodor's weld depth reaches 4mm at 1200 watts, 5mm at 1500 watts, 6mm at 2000 watts, and up to 8mm at 3000 watts. That's well above the typical performance in this category. We call it next level performance, delivering superior weld quality that really sets you apart in production.
Alright, before we jump into questions, let me just put it all together for you, please, Alex.
Okay. Today's webinar, we made it clear, whether it's the Pro, Air or Eco Series, Bodor handheld laser welders are designed to make welding faster, easier and more efficient. They're up to 3 times faster than TIG, especially on thin sheets, and incredibly easy to use, thanks to features like one knob control and auto wire feeding. Weld quality, clean seams, deep penetration and minimal distortion, even on tough materials like aluminium and stainless. And beyond the welds, they save on gas, power and labour. Some workshops are cutting labour time in half. These machines are built to run hard, clean and deliver full rated power with real depth, up to 5mm at 1500 watts. So to sum it up, fast, stable, easy to use and built for serious productivity.
Alright, now let's jump into our interactive Q&A. If you are dropped questions in the chat, thank you. We are also prepared answers to some of the most common questions we get from users around the world. Alex, let's click it off. Alex, in what scenarios can handheld laser welding replace TIG welding?
Great question. Handheld laser welding really shines in applications like thin sheet welding, especially 4mm and under. And for parts where the appearance really matters, like kitchenware, home appliances, signage, and decorative finishes. It also has an edge in tight or complex weld angles, like inside corners or edge seams. Because of the heat-affected zone is much smaller, the welds come out cleaner and more precise, often with no need for post-grinding or polishing.
Here's another one that comes up often during demo trials. What if there's a slag or inconsistent weld seams during operation?
That's something Bodor designed around. Our handheld laser welders uses an internal process library that automatically matches the right power and settings to the material type and thickness. You just adjust using the single rotary knob. That takes a lot of the guesswork out of the process and really reduces operator error. And thanks to our wide voltage compatibility, the machine also stays stable even during voltage fluctuations, avoiding weld roughness caused by unstable laser output.
Can Bodor's handheld laser welder also clean or cut?
Yes, absolutely does. Our handheld laser welder isn't just for welding. It also supports cleaning and even cutting, depending on the power. If you attach the special cutting nozzle, it turns into a laser cutter. For example, the 600-watt model can cut through 1 to 2mm of metal, and the 1200-watt version handles up to 4mm, clean and precise. And when it comes to cleaning, it can remove rust, paint, and surface impurities before welding, or clean up oxidation afterward. All Bodor laser handheld laser welding series torches are available with a wide cleaning width of up to 120mm.
Thanks again, Alex. Before we wrap up, we want to highlight something important again, especially for those of you in industrial sales or manufacturing supply. If you are looking for your next big opportunity, this is it. We are actively recruiting global partners for our handheld laser welding series, and now is the perfect time to join us. As a Bodor partner, you will unlock exclusive first order discounts for limited time, pre-qualified leads in your local market, full product coverage in welding, cleaning, and cutting, expert training and ongoing technical support, access to a fast-growing, high-demand market, and yes, high margins and big bonuses for volume. So if you are ready to grow with the world's #1 laser equipment brand, don't wait. Book a partnership conclusion today, and let's build something great together. Alright, that brings us to the end of today's webinar. We hope it gives you a clear look into what handheld laser welding can really do, and how Bodor can help your business level up. And of course, a huge thank you to you, Alex, for walking us through everything today.
Thanks, Cece, and a big thanks to everyone tuning in. Really great to be part of it. Thanks.
And to our audience, thank you so much for spending your time with us. If you are ready to explore Bodor's handheld welders, book a consultation, claim your promo, or ask about distributor opportunities, just email and our team will take care of the rest. That's it from us today. Until next time, stay sharp, stay efficient, and happy welding. See you soon.
Bodor, Dare to Dream.